Welcome to today's webinar, Delivering Static and Dynamic Content Using Amazon CloudFront. First, let me introduce today's presenters. Today's webinar will be presented by Alex Dunlop and Andy Rosenbaum. Alex is Senior Manager for Amazon CloudFront, and Andy is Director of Web and Desktop Development at Earth Networks. With that, I'm going to hand it over to Alex.
Las Vegas. For anyone who was able to join us, this is the same talk that Andy and I gave in our breakout session. But hopefully for other folks, this is new content and you'll learn something. So with that, let's go ahead and get started. What I wanted to do today is really three things. I first wanted to explain to you how you can use Amazon CloudFront's features to deliver your website with a focus on the features we've built for dynamic content. So traditionally, CDNs have been focused more on static content. In 2012, Amazon CloudFront has added a lot of features focused on the dynamic side of the business. We'll define what dynamic content is, how it's different than static content, and talk about those features. The second thing we'll do is to show you a hands-on demo of Amazon CloudFront in action. And then finally, we'll hear from Andy Rosenbaum at Earth Networks. So with that, let's get started. Most sites today use a mixture of static and dynamic content. Dynamic content is the stuff that changes from users to users. So you see here, this is a screenshot we've taken from the Amazon.com retail site. Jared, who gave the introduction, this is his Amazon.com, so you can see his name in the upper left of the screenshot. On the other hand, static content is the stuff that doesn't change from user to user. So everyone visiting on this day would see the Kindle images or the Modern Family image that's there in the center. That's considered static content because all the users get the same content. Let's drill into those in a little more detail. So we define static content as the objects on your website that don't change from user to user. These include images, media files, audio scripts. Again, the key thing here is that these are the objects that don't change from user to user. Everyone gets the same one. Dynamic content, in contrast, is the interactive or personalized portion of the website that's created on the fly for each end user. So this could be the customer's name, like Jared's name on the screenshot we saw earlier, or personalized information, things that we tend to see, news, weather. People want the weather where they are, so personalization in weather and sort of the news stories are very important. Sports scores, stock quotes, travel information. All of these things are very personal, and they change from user to user. So the old way for delivering dynamic content, customers had what we consider to be two bad choices. The first was to use their own origin server and to deliver content directly from those origin servers, so basically not use a CDN at all. This was slow. This was hard to scale. You had to make sure that your origin infrastructure was up to the load that a potential flash crowd could put on it. It introduced single points of failure and was expensive. You had to handle that load. On the other hand, there were solutions from traditional content delivery networks that worked for dynamic content, but these were expensive, they were complicated to configure, and they often required proprietary coding in order to get them to work. So we built some features into Amazon CloudFront for dynamic content with really three tenets in mind. The first was to make it simple to use. We wanted a service that you could configure yourself using our web console. No consultants should be necessary. There shouldn't be any proprietary languages to learn. We wanted to build a product that was integrated with other AWS services. Connectivity between the Amazon CloudFront Edge locations and the AWS regions very closely. And we allow CloudFront resources to be configured with standard AWS tools like Amazon CloudFormation that can provide scripting to set up your CloudFront distributions plus your origin. Finally, we wanted the service to be low cost. This is very consistent with how Amazon has approached the web services business overall. We didn't want you to pay any additional charges so for dynamic content, so there's no setup fees or upfront charges. We only wanted customers to pay for requests and data transfer. And in fact, we made the decision to price it at the same rates that we charge for static delivery. So how it works, there's two layers of optimizations here. The first, two layers of network optimization. The first is between the user and the CloudFront edge location. So like our static content, or any kind of content, we will choose the location that is best positioned to serve an end user based on low latency. We have optimized the TCP settings on those connections, and we maintain persistent connections between the edge location and the end user. Between CloudFront and the origin, we have features that allow the separation of static and dynamic content. I'll talk about that in a little more detail in a moment. We maintain persistent connections to your origin, and we monitor those paths for performance. So here in this example, we have a CloudFront distribution that sits in front of two different origins. Dynamic content is handled by an ELB, Elastic Load Balancer, in front of an EC2 cluster, and static content is delivered directly into Amazon S3. All that content would be delivered from a single CloudFront distribution and with a single CloudFront domain name. Those edge locations are all over the world. We currently have 38. Sorry, excuse me. You can see the list: America, Europe, Asia, and Australia. Performance is really what we're all about. This is some information that we gathered from actually a customer of ours Amazon.com. The retailer uses CloudFront to deliver the images on its retail website. They didn't make this switch until they were comfortable with Amazon's performance, Amazon CloudFront's performance. They know that performance of a page, how long it takes the page to load, has a direct effect on end user experience. So they didn't switch to CloudFront until they were convinced through their testing that CloudFront was going to perform as good or better than the other CDNs that they had previously used for their site. So with that, let's take a deep dive into the features for Amazon CloudFront. I'll start briefly by describing some of the features we use for static content delivery. We can deliver with CloudFront content over an HTTP or an HTTPS, an SSL connection. We have options to do video streaming using both HTTP or RTMP. Private content lets you control who's able to download your content, so you can provide signed URLs that provide a policy that determines whether a URL should be served or not. We offer invalidation, the ability to remove something from cache before its expiration. Access logs give you the ability to report on or do analytics on who's delivering your content. And everything that you can do with CloudFront, you can do via APIs. This is just a subset of the features we have for static content. We take a very incremental approach to development here at Amazon. So we started CloudFront in 2008 with a basic service that did HTTP delivery. Over time, we've added a series of features. These are some of them. There are some others. But these are some of the key ones that we've added on the static content side. I want to talk now about the features we've built for dynamic content and really talk about four groups of features. The first are connection optimizations. The second are multiple cache feeds and cookie strings. Sorry, query strings and cookies. We'll talk about each of those four as features that we've built for Amazon CloudFront for dynamic content. Optimized connections. I alluded to this in the graphic, but there's really two pieces to this. The first and the second is between CloudFront and the end user. Basically, between the origin and CloudFront, we monitor the paths between our edge locations and Amazon EC2/S3 data centers. So we are able to make sure that the long-distance path over the internet is over a connection that we monitor for reliability and performance. We do collapse forward requests, So if you get multiple requests, if a single edge location gets multiple requests for the same piece of object at the same time, we will collapse those into a single request to your origin. That both improves, reduces load and improves performance. And we will maintain persistent connections between our edge location and your origin. CloudFront to the user, in addition to TCP optimization and connection optimizations that I talked about, routing is really the key thing we do there. So we select the edge location that is best able to serve the content in terms of latency. So we have a lot of, spend a lot of time worrying about whether, which of our 38 edge locations are best able to serve a customer's request. For multiple origins, is the second feature I'll talk about here today. This allows you to separate content into different origins and use a single domain name to access your content. So what some customers do, you see the picture of the Mars rover here. The NASA folks spoke at our reInvent conference. They actually used CloudFront's multiple origin feature when the Curiosity lander landed on Mars. It was going to send back the photos that it took from the surface of Mars, and those photos would ultimately be delivered through a website that was hosted on AWS. The website was all set up with a single CloudFront domain name, but it consisted of an S3 bucket where the images were served and two ELB clusters that were fronting EC2 instances that constructed the website around those images. All of that had a single domain name that was given out from CloudFront. So they were able to separate one into S3, the dynamic stuff went to ELB. They had an organizational scheme that worked with their CMS, and they incorporated all of the different back-end services together using a single domain name that was in fact an edge domain name from Amazon CloudFront. Cache behaviors. Cache behaviors tell you which origin you want to use and a variety of other settings like SSL, private content, the minimum TTL, and the use of queries and cookies. Cache cookies or query strings that we should use based on a request pattern. So for each request that we get, we are going to look at the request and match it against patterns that you specify. So some customers will say anything that's in a static star path I want to treat as a static object. Send it to a Amazon S3 origin and use a long TTL. Anything in a dynamic path I want to send to a ELB origin and use a 0 TTL. Anything that ends in .jpeg I want to treat as static. So CloudFront will apply pattern matching on the requests that come in. We call these patterns cache behaviors to determine the origin and which cache settings you want to use. Finally, queries and cookie strings are a way that you can personalize pages and sites to individual users. Basically, you will provide a whitelist to CloudFront of cookies and query strings that you want us to forward to your origin. We will consider any cookies or query strings that you specify as part of the cache key. Basically, that means that we will vary our content based on those cookies or query strings. So this is an optional feature that allows you to cache user-specific information using Amazon CloudFront. So with that, I'm going to go on to a demo. I'm going to take a moment here to switch out. So I'm going to put my screen on pause. All right, let's go ahead and show the screen. So what we've built here is a very simple Twitter application. We've actually built it in Elastic Beanstalk. And what we do is the origin will return the top 3 hashtags that are trending on Twitter. And so you can see that I've done that here. This is my origin. And it shows that here are the top 3 hashtags. It's dynamic, so every second you can get different results. You see that between the first time and the second time I refreshed that, there was a change, not. The second thing that's our example of dynamic content. The second thing we've done is we've taken a very simple image. This is the Amazon Web Services logo. We've gone ahead and we've put this into an Amazon S3 bucket. So that will be a second origin that we use. It's going to be static content. The third thing we've done is we've created a second Elastic Beanstalk application that basically serves as a web server, wrapping those three things together. And so here this will ultimately combine, it's not combined together right now, live random data, which is going to be our Twitter feed, the Amazon logo, all on a single index.html page. So let's go ahead and let's log into the Amazon Web Services console. And so I'm going to log in. What I've done is I've actually created three different distributions, three different cache behaviors. The first behavior looks for anything ending in HTML and sends it to this this origin. The second thing says anything that ends in PNG, GIF, or JPEG, I want to treat as static content and send to this origin, a dynamic service that returns the top three hashtags. So here's the distribution with the result, and you can see that it all gets put together. We can see the three trending hashtags that gets updated every second. All of this stuff is coming directly off of a CloudFront distribution with a domain name. And so you can see that the top hashtags just changed. Again, this is all live data that comes live as it happens. If you want, this is not a very customer-friendly, D286. So I originally did this demo at reInvent, and so here we can use a customer-friendly name. It'll create the graph once again, and you can see it. So again, we're combining in a single CloudFront distribution, dynamic content, static content, all delivered from a single distribution. So with that, I'm going to turn things over to Andy from Earth Networks, who's going to talk about Earth Networks' experience with AWS and CloudFront.
All right, I'm going to switch this over to Andy. Andy, I hope you're ready.
Yeah, I'm ready.
All right.
So hopefully you all can see my screen. Is it coming out right?
We can.
Great. So thanks, Alex. Thanks, Jared. My name is Andy Rosenbaum. I'm Director of Development for Web and Desktop Products at Earth Networks. My focus is to really continually evolve the Earth Networks online presence. And because the CDN is such a critical part of our architecture, I work very hard to really keep ensuring that we optimize our cache usage, both in terms of performance and to manage our costs. I've been in software engineering for over 15 years and developed primarily within the Microsoft stack. What I'd like to do today is give you some insight into how we arrived at the decision to switch CDN providers to Amazon CloudFront, and a surprisingly complicated process that then ensued, a process that didn't have anything to do with Amazon CloudFront itself, but was actually due to a hard dependency that we had on our previous CDN provider. So real quick about Earth Networks. Earth Networks owns and maintains sensor networks, and we're probably better known for our WeatherBug branded properties. We utilize vast sensor networks to provide a view on the state of the planet using weather observations, greenhouse gas, live hyper-local information to our end users. And when it comes to weather safety and planning, this is a really critical value proposition. Our user base includes consumers of our WeatherBug branded properties. That's over 40 million users and hundreds of millions of page views monthly. as well as our enterprise clients and a growing international client base as well. One of the things that makes us a little bit different than other weather companies is that one of our clients is actually the National Weather Service itself. So when you see thousands of apps out there and websites all getting their information for free from the National Weather Service, that data is actually partially generated dynamic. Whether you're using it for planning and for safety, people want weather information that is relevant to them. And with millions of users accessing our data, we need to be able to ensure that we prevent, while at the same time maintaining the integrity of our core systems. The CDN is a critical part of our architecture, that decisions that are ultimately made by our users. As much as they rely on us on a routine basis just for seeing how they're going to plan out their day, their expectations are that we will just be just as reliable during severe weather, which is when they really, really need us. Amazon CloudFront helps us ensure that we're always there for them, regardless of the load or the weather. The increase in the number of page views scenario would mean essentially having a siloed infrastructure that could support 8 times the load, but really only needed 10 or 20 days out of the year. And that's not really efficient or very cost effective. What you want to do is scale yourself horizontally and utilize a CDN like Amazon CloudFront and optimize your cache to limit the impact on your infrastructure while still being able to serve up all that important information to your users, especially during these kinds of load spikes. Another example during Hurricane Sandy, to very quickly make some cache rule adjustments on the fly to free up some capacity in the database. Amazon CloudFront allows us to react to the changing weather and load patterns and adjust cache expiration times and time to live very quickly to ensure that we're able to retain the user experience and the stability of our core systems. Now, one of the biggest hurdles we knew we were going to face when we were considering switching CDN providers was the scope of how dependent we were on our previous provider. We had spent the last 6 years optimizing our code, our architecture, and cache structure to get the best possible cache hit ratio and edge offloading. And this meant another fit for us was to get away from having this custom implementation, allowing us to move faster with changes. The amount of time it was taking us to iterate through releases was extremely high due to the customized nature of the code. What should have been hours was taking us days to code and test. And not only that, the technical knowledge of the system and architecture was really restricted to the point that only a select few within the company could develop, test, and support it. And really by select few, I mean pretty much one. And that person was no longer really had the capacity to continue to be the sole resource for it because he was going to be doing things like webinars. And the other reality was that our costs were sky high, and we were paying for a large feature set that we weren't really taking advantage of. Performance wasn't the issue, but the cost really caused us to take a hard look at our ROI that we were getting. And what it boiled down to was we needed a high-performing CDN that supported dynamic content. And that was our first and foremost objective. In our current situation, we were basically trying to crack a nut with a sledgehammer. It did the job, but it made a mess if you weren't really careful, and it was really overkill for what you really needed. So the question became, could we get the same level of performance out of Amazon CloudFront, and would it meet enough of our needs, both currently and in the near future, for it to be a viable alternative for us? But most importantly, could we move our high-profile properties under Amazon CloudFront? So why Amazon CloudFront? This project started as these projects typically do with my CIing and asking me to stop by his office, which usually means either something's broken in production and he's really unhappy, or he's about to drop a project in my lap that he knows is going to give me a little bit of heartburn. In this case, it was the latter. We've been evaluating CloudFront, since it was a static content provider to now it being a dynamic CDN, and he wanted to know, was it ready for us to use them as our primary CDN provider? And my answer to him was, yeah, they have a great there's very significant benefits to moving to Amazon CloudFront. Whether you're looking at platform optimization and partner management consolidation, the great performance that we're seeing out of there, the simplicity of the configuration and the setup, or the very significant cost savings, it was definitely worth considering switching. And his reaction was, he looked at me and said, "That's really great. That's exactly what I wanted to hear. Our contract is ending with our current provider in 4 weeks, so I'm not going to renew it. So you got 4 weeks to move everything." Now, so while the right side of my brain is convincing myself of all these great benefits of switching providers, the left side of my brain is trying to figure out how I'm going to move all of our properties over in 4 weeks, obviously without implementing any other projects and with obviously very limited resources. Now, for the most part, implementing CloudFront is very straightforward. However, there are several properties that we had that were very high revenue and very large user base, very high visibility, that I knew were going to be a lot more challenging due to that legacy dependency that we had on our previous CDN. So after once again committing myself to a very difficult time frame, I spent some time digging a little deeper into Amazon CloudFront to see how the fit was for our current product portfolio. And as what you would expect with any new platform offering, there were some gotchas that we ran into and some features that aren't available yet. And we provided this feedback to Amazon CloudFront team, and we're very happy with the response that we've gotten and the plan that they have in place to further evolve the platform. However, it is important to note that when you're looking to move to this platform, it might not be all unicorns and rainbows for you. There are definitely some key items to note. Case sensitivity and order sensitivity. Nowadays, people don't really type in full URLs anymore into the browser manually, so it might not be a huge impact for you, but it may impact your cache hit ratio and performance, and it does make it a little bit harder to get full coverage with your cache rules. Host names aren't passed through to the origin, so if you're doing any domain-based license keys or domain-based configuration in your code, this will impact that. No form post support. This is obviously going to impact your ability to submit items to HTTP posts, things like images, videos, documents, etc. That content is actually not passed through to the origin. And finally, for us reporting, and this is actually really important for us because this gives us visibility into the performance of our cache and the CDN, and it helps us continually optimize. Right now, they have all the data, but it's all in log files, so there's no user interface for you to very quickly look at your overall cache performance for things like cache hit ratios, edge offloading, or edge errors. Now, you can obviously work through a lot of these through code if you really want to, do very basic code changes, but in the end, none of them will really show stoppers for us to move forward. So once we made the call, we basically had to take inventory and identify the properties that we were going to move. And for us, it broke down into 3 categories. One, ones we weren't going to move due to a need for a feature that wasn't yet available in Amazon CloudFront. 2, the ones that were very straightforward and easy. And 3, the hard ones. And the hard ones were the ones that would require moving away from that old architecture, and we would have to perform some very heavy testing to ensure that it would work actually in Amazon CloudFront. In total, we identified around 10 properties, 8 of which fell into the easy category. And the other 2 fell into the hard, and those 2 were our flagship desktop product and our mobile web product. Now, the reason that these were so hard was that under our previous CDN, we were able to optimize our cache through a customized implementation of fragmented HTML calls. So each page was actually cached and constructed at the edge in fragments. A user would make an HTTP request, and then the edge would call the origin for the page architecture, determine what fragments of the page were already in cache and what needed to be fetched. We would then fetch those items asynchronously based on individual time to lives and return a fully constructed page as a response to the user. All the user information is maintained through a combination of query string values and cookie values, so we needed to be able to take advantage of those Amazon CloudFront features in order to ensure the migration was even going to work. Being able to pass that information through to the origin and actually have it be part of the cache key is what actually allows us to deliver that localized, personalized, and real-time information to our users. So in the end for us, what we really wanted to evaluate was the performance differences between the 2 CDNs. We already knew the cost savings, and the real only major showstopper for us switching was going to be performance. I'll save you the tedious details of how we removed that customized architecture to allow it to work under Amazon CloudFront, Suffice it to say, the CDN should be part of your architecture, but it should be an interchangeable part. And we were ultimately able to get to that. So the key to really comparing CDN performance is to remove any other variables and have the only difference be the CDN. We ran 2 separate instances with the same infrastructure setup. Then we would use our IIS logs to play back load against the 2 siloed pipelines. What we wanted to see was there any noticeable or measurable performance difference between the two, and we needed to measure this all the way from the user to our back-end systems. Did the user experience any downgraded performance, or did our origin web servers observe any insignificant performance or load issues? And finally, did our back-end experience any increase in load? And the answer across the board was no. Users perceived no change in performance or stability. And in fact, we saw slightly higher performance out of Amazon CloudFront's edge to the user than we saw out of our previous CDN. And this is later verified by a white paper that they published, which showed similar performance gains to what we saw in our testing. So if you have a chance to look at their white paper, I highly recommend it. Now, one of the reasons that we got such great performance was we took the time to make sure we got an optimized cache structure and rules. We continued to monitor and adjust it. You know, our experience with edge caching in the past was really helpful here, as was just having a solid understanding of how our users use our products and how data actually flows through our system. So to summarize real quickly the testing, you create your duplicate environments where load can be run against both CDNs in parallel. Try to eliminate other variables from your testing. Identify baseline performance metrics, give you insight and a minimum threshold goal to reach. You monitor your web server performance, look for increases in requests per second. Re-optimize your cache configuration and keys and your time to live values. Go back and verify functional consistency between your environments. Verify your edge hits are actually being made via HTTP sniffer. Part of the response header that comes back from CloudFront is actually a value that tells you whether or not it's a cache or a hit or a miss, which will help you verify that the rules that you set up are actually doing what you're expecting them to do. And finally, you want to verify your user experience, both the actual and the perceived. Just because your reports and everything say it's fast, are the users actually experiencing that speed as well? To give you some quick closure to the story, once we got everything set up and configured, we picked a Monday to go live. And of course, that weekend I actually flew out to California to meet with one of our other dev teams. So that probably wasn't real well thought out. We flipped the DNS over to go to CloudFront, and despite all the testing and verification we did, everything immediately broke. We had alarms going off on our monitors, and emails were flying around. And it had absolutely nothing to do with CloudFront itself. It turned out we actually had some server configurations combined with a small piece of code that optimized under our previous architecture that we missed in our testing. And in production, it actually caused a stability and performance issue when under heavy load to available thread limitations. We were starving our thread pool, and our instances were failing their health check in the ELB, and then they were getting kicked out. So we, after engineering a quick new release out and a quick tweak to the config, everything calmed down. We were able to send out an all clear message, and we've been running fine ever since. So as of today, we moved 10 properties under Amazon CloudFront, including our flagship desktop product, as well as our WAP product, and several static file domains, as well as some dynamic data feeds as well. With millions of active users, we're still able to retain the overall user experience when it comes to both perceived and measured performance. Our cost savings are over 50%, and this also takes into account the anticipated traffic of the remaining properties that we haven't yet migrated. Total time for the migration took 4 weeks, and in terms of what's needed for Amazon CloudFront, the setting up is very simple. You add your property, define your cache keys and your cache rules and configuration, and then point your DNS to the new Amazon CloudFront domain, and you're pretty much done. But even for those basic ones, we still took an extra step to spend about a day doing some basic testing to verify our rules. So we were able to move the 8 easy ones in about a week, doing about 1 per day. The hard ones that I mentioned earlier took about 3 weeks between development and testing before we were able to switch the DNS over, watch it all blow up in our face, go back and fix it, and have it work fine. Hopefully the properties that you're considering are going to fall under the easy category. So the end goal for us is to have all of our web properties, whether they're websites or feeds or static content, fall under Amazon CloudFront. And though this isn't the end goal, this is the end goal. It's not the end of the overall journey. You know, we continue to monitor and adjust our cache rules to best optimize performance for our users and our systems, both as the Amazon CloudFront platform and our products and users evolve over time. I'm really encouraged with the rate the Amazon CloudFront team has grown the service and the features that they offer. I'm really looking forward to continuing to work with them as we partner together on our individual journeys. So that's it for me. Thank you all very much, and turn it back over to Alex.
Thank you, Andy. We're going to go back. We're going to transfer this to Alex real quick. And malfunction there for a sec, so we want to go back on that?
Yeah, I just wanted to take you through, I intended to take you through the AWS Management Console and sort of show you what we did in the console. So I've got the console up, so this is the application again. What you'll see is I have created a download distribution, and it has two CNAMEs. So the one that I was using, this is alternate. CNAME is an alternate domain name that you can use to access your distribution. So I was using reinvent.cloudfrontdemo.com to access this. So this is the basic setup. The other thing you'll notice that I did is I set up a default root object of index.html. So if we get a request just for reinvent.cloudfront.demo, I'm going to send that to index.html as my default. In terms of origins, here are the three origins that I created. So you'll remember origin by itself is the actual application that pulls back the hash tags. Origin 2 is the wrapper that puts together the web page. And the S3 bucket is where I store my static images. Here you can see the rules. So you see that anything, these are what I called cache behaviors. These are the pattern matches that I talked about in the presentation. So you can see that anything that ends in .html or .javascript, I'm going to send to my origin 2. So that's where I have my application that has the website. Anything that ends in JPEG or PNG, I'm going to send to Amazon S3. And the remaining stuff I'm going to let fall through to my application for the hashtags. You can also see that for my dynamic origins, particularly here, I'm forwarding the query strings from the user. That's a feature that my dynamic origin could support, so I'm going to send those back from my CloudFront distribution, and we'll include those in the cache key. But for the static stuff, the S3 stuff, I'm not doing that. I'm also not doing that for the HTML. So that's how I set it up. It was very easy. It just took a few minutes to do. But it combines 3 origins, 5 cache behaviors, default root object in order to give you a single site that lets you display all of your content using Amazon CloudFront. So I'm going to go ahead and pull back up the slides here. It'll take me a couple of seconds to get back to where we were.
Well, thank you, Alex, and thank you, Andy. We're going to start by taking a few questions from the audience. We're going to go back through some of the ones that have already been submitted. And we'll go through some of those now. So with a question for Alex. There's typically, and this is from Ashley, there's typically a significant time delay in invalidation of objects. Is there any way possible to force an instant invalidation of an object across all edge locations?
So invalidation is inherently a complicated process. What we're basically doing is going out to every cache server and every edge location and saying, if you have an object, this object in cache, please get rid of it. Typically, invalidation activity is complete in about 15 minutes, which is actually a fairly short amount of time to do such a complicated operation. If you do have a use case that you know ahead of time will require shorter times than that, invalidation is probably not the right tool to use. Invalidation is really best used in situations where you make a mistake. You put something up with a longer expiration period than you intended, and you need to get that out of there. But for things you know are going to need to change quickly, the first thing I would recommend is to look at our look. So just set a TTL that reflects the cadence at which you expect your content to change. The other thing I would recommend you look at is object versioning. There's actually a forum post in the CloudFront forum that talks about best practices for object versioning, but object versioning will allow you to do that sort of instantaneous change. What object versioning is basically just where you create a new version of your content, give it a unique URL, and then include that unique URL in your website or your application. That basically eliminates the need to invalidate.
Okay, along the same line of question, if my static content origin is S3, deleting a file from the S3 bucket will
no, that's a separate activity. So if you delete the file from S3, you'll want to then follow it up with an invalidation if you want to make sure that it's removed from all of our caches. You always want to work from the origin forward, so whether it's S3 or another origin, make the change you want at your origin and then do the invalidation command, not the other way around. That's how we ensure that. That's how you ensure that you don't get stale stuff into cache. But if you want to if you delete something and want to make sure that it is purged from all of our caches, you would want to separately call the CloudFront invalidation API.
Okay, thanks, Alex. Chris asked, are there plans to support all HTTP verbs to support RESTful services?
Yeah, we take an incremental approach to development. So certainly this is something that we have on our list and are considering. We know that there are certain use cases that really do require all the verbs. We right now have sort of one-way verbs, get and head, that deliver content from the CDN to the end user. We've heard from our customers that they want to go both ways, if you will, so proxy stuff through the content delivery network back to their origin, and that's something we're considering. I don't have any dates to announce at this time, however.
Okay, thanks, Alex. This one is from Gary. How do you geolocate a user? Does CloudFront pass an IP address?
So what we do is we look at the user's DNS resolver and we make a estimation as to which of our edge locations is able to serve the request with the lowest possible latency. It's not strictly based in geography, so if there are cases where someone is geographically closest to POP A but the lowest latency is to POP B, we will send them to POP B and not POP A. So we found in our experience that while geography is a reasonable proxy for latency, it's not always perfect, and there are circumstances where a POP that's slightly further away in miles may actually be closer in milliseconds of latency. In those cases, we're going to do the milliseconds and not the miles.
Okay. Here's kind of a unique one. This is from Steve. He asked that, he said, let's say I have 100 webcams and they produce a 100 kilobyte JPEG. I want to upload 100 new images every 5 minutes. Is this a reasonable use of CloudFront if I expect a lot of access to these images?
So I would separate in that question the upload from the download. And so the upload, as I talked about earlier, is something that you cannot do through CloudFront at this time. But from the download, if you do expect a high rate of access of these content, yes, CloudFront is a great application for CloudFront. I believe we have a customer, I won't name them because I don't know that we can talk about them, that's doing traffic cameras via CloudFront. And so that's a great example of a webcam that you want to sort of share broadly with a large group of users. So what this customer has done with CloudFront is used it to show photos of intersections and highways that may or may not be congested at a given point in time. So that's a example use case where webcam content may end up being delivered through CloudFront successfully.
Okay. Thanks, Alex. Here's kind of a broad one, and it's from Ronzo. He said that we're considering Amazon CloudFront and some other vendors, and he's asking what differentiates CloudFront versus other CDN vendors regarding dynamic websites.
So I'd focus really on the things that Amazon CloudFront focuses on for all parts of our business, and really what AWS focuses on in its entirety. The first thing is reliability and performance. We focus on making CloudFront a highly reliable, high-performant content delivery option for you. So it's our goal to deliver your content as fast as we can and as reliably as we can We mentioned earlier a white paper that we have up on our website that talks about how we do in that respect, particularly on the performance side. So you can take a look there. The second thing is ease of use. We believe very firmly that you should be able to configure CloudFront, whether it's dynamic or static, very simply with our CloudFront management, AWS Management Console. That should be true if you're configuring CloudFront via the console. It should also be true if you want to integrate your back-end systems with CloudFront. So anything you can do with CloudFront, you can do with an API call or the console. There's no need to hire consultants. There's no proprietary code. It's designed to be super simple for the customer to configure, make changes. Anything you can do with CloudFront, you can do on your own. There's not a sort of ticket that you need to file with a vendor to get something set up. It's all designed to be super simple and self-service. The third thing is integration back with other AWS services. So when we started CloudFront, we built it from the ground up to work great with Amazon S3 for static content. It still does that. We this year added integration points with other AWS services, specifically Amazon EC2 for dynamic content. So we really believe that CloudFront is a great solution for customers who are running their origins in AWS infrastructure. And then finally is cost. We have built CloudFront using AWS's philosophy towards pricing. So there are pay for what you use options. So the default is you only pay for the content you deliver for the service without any minimum fees or any upfront charges. You never have to give a long-term commitment. We also have a precedent here of giving features that were traditionally presented as premium features at the same prices that we charge for static delivery. So we did that when we launched on-demand streaming. We did that at the same price that we charge for HTTP delivery. When we did live streaming, we did the same price we charged for HTTP delivery. When we did private content, we did it at the same price we charged for HTTP delivery. When we did, most recently, dynamic content, we did it at the same price we did for HTTP delivery. So we have a long history here of giving customers low prices and good value for features that were traditionally premium features.
Okay, Alex, this is from Ian. How tightly does CloudFront honor the cache control header, such as max age equals 1800?
There are some nuances in how you set those headers, but we will behave according to the spec. So max age is what we'll look at when we're doing caching as well as the other cache control headers.
Okay, several questions on TTL. Since we're talking about this, we'll just continue a couple more. This is a follow-up from Ashley from an earlier question on TTL behavior. Do you favor using behaviors, low TTL behavior, say 1 minute over versioned objects? Is there a significant benefit to using such low TTLs instead of just serving requests direct from the origin?
So there's a couple questions in there, and it really depends on your use case. These questions are often hard to answer in the abstract. If you can do it, what I'd suggest you do is try it. And one of the other services we offer here is Amazon Route 53 that has a weighted round-robin feature. So if you have good instrumentation on your site, what you could actually do is do an A/B test that looks at performance using low TTLs versus object versioning. Use one approach for half your site, the other approach for the other half. There's not a rule that says this is always better. It really depends on the specifics of your use case.
How about this one, Alex? This is from Jason. Our static web server is currently Nginx running on EC2 instances behind the USB. With CloudFront, it seems possible to phase out the web server entirely and keep all static files on CloudFront. Is that a correct assumption?
Yep. With the information you gave me, that does seem reasonable. So we do very well at serving static content. So that seems totally reasonable.
Okay, this one, Andy, are you still on the phone? You can take yourself off mute if you're.
Yep.
Yep. And I'll throw this to both you and Alex, just to get a real use case to see if you might have an answer for this guy. This is from the single domain solution. Is there anything out there that I can look at that would give guidance on getting around this problem? And also, that's both you. Andy, you might have done something with one of your web properties. If not, that's
I think the short answer is separate domains.
You need a separate domain.
Go ahead, Andy.
No, I'm sorry. That's the short solution, is to actually create a second domain and not route it through CloudFront.
Okay, thank you. Another TTL. What is the lag time on changing? This is really similar to another one, I think. But what is the lag time on changing the minimum TTL in the cache behavior setting?
So that's usually around 15 minutes. That's the time that it takes for your distribution to go in sync in the AWS Management Console.
Okay. All right. Well, we're getting up to the top of the hour, or getting close. So I wanted to thank everyone for attending the webinar. Thank you to Alex and Andy, and thank you to everyone for attending today's webinar. Those who attended content using Amazon CloudFront, you can always go to our detail page, aws.amazon.com/CloudFront. Thank you.
Thanks, folks.